Everyone, welcome to this video on lesson 15 of the Sound and Light scheme, which is about white light. This is moving on from the sequence of lessons we've just done on refraction, showing how light behaves when it moves from one medium to another and changing direction. This is really the introductory lesson to a new topic, or a new kind of mini sequence of lessons, I suppose, about white light and colour, which leads into the electromagnetic spectrum. But actually, it's a nice linking lesson in that to understand how we discovered the different colours that make up white light. We need to have encountered refraction already. Because we're going to look at prisms and rainbows, and both of those are based on the idea of refraction. Now, in terms of this video, I'm going to do a kind of basic introduction to white light that I would do, let's say, for low prior attaining classes at first, and then I'm going to add a kind of extra bit in the second half of this video, which you might want to leave for maybe higher prior attaining classes, because that looks at Newton's experiment and how he came up with this idea that actually white light is made up of lots of different colours. That's a little bit more challenging, and it maybe goes a little bit beyond what every single student needs to know, so I will leave that to your discretion, whether you choose to focus on that or not. But I think it is worth introducing Newton again. We came across him right at the beginning of this scheme of work, looking at theories of light and how Newton thought light was made up of particles. And I mean, there's a really nice, you can tell lots of nice stories, and I won't bore you here, but it's worth reading up on Newton's work on optics or light. Quite a bit of it was done during the Great Plague, and obviously in our own lifetimes and students' lifetimes, we've had our own Great Plague with the COVID pandemic, and yeah, it was certainly a sobering thought to me to realise that Newton reinvented our ideas about light during the lockdown. I'm not sure what I did during that period, but anyway, not quite as successful as Newton, but never mind. But what he did was some experiments, essentially that involved shining light through what's called a prism. And it's definitely worth having a prism in the lab. This is a word students probably won't have come across before. And you can show them what happens, and I'm just going to draw it here, how I might draw it for students in class to show them what's going on. So if we show a beam of white light looking like this, and I'm deliberately drawing it a bit thicker than probably it is in reality, but if you can kind of demonstrate this to them under the visual lab, that's really helpful. And what's important is they recognise that what is going in is really the same as what's coming out. There's just something that the prism has done to make it appear slightly different. And Newton's idea was that, well, now firstly, before we get to Newton, what do we see when we shine light through a prism? This is what we see. We see some refraction. So there's nothing different to what we've been talking about before. And you start to see the colours of light. I don't have all the colours of the rainbow here, but I do have a few. And I'm going to show these colours refracting by different amounts. So I'm going to show red at the top, refracting the least, blue at the bottom, refracting the most. And then I'm going to show prism is a bit of an awkward one. You could recap on whether things bend towards or away from the normal, but the prism makes things a bit confusing, and you might just end up in the weeds if you're not careful. So I'm just going to sketch it like this. But essentially what I want to show is that the colours of the rainbow, and if you've got yellow and orange and purple, or, well, we shouldn't call it purple, should we? Indigo and violet. If you've got those colours, feel free to use them. I'm just going to do these three for now. But what we need students to recognise in really, really simple terms is that what's happening here is that light is refracting. And the fact that you've got a prism causes this real exaggeration and this splitting effect. But what we need to understand is, well, how is it that we get from white light over here to the colours of the rainbow over here? And it's very easy to say, oh yeah, it refracts, and assume students will know what's going on. What they really need to understand is that these different parts that are observable here, they were all present in the white light that you had to begin with. It's kind of a conservation idea that there's nothing, nothing's been invented, nothing's been created or destroyed here. What you end up with is what you started with. But Newton's big idea, how Newton explained this, was to say, well, actually, all of these colours of the rainbow, when taken together, our eyes perceive those that suite of colours as white, as perfectly white light. And this was a kind of mind-blowing idea, as we'll see. And this is the idea that you want to get across to students. Now, in terms of how to explain this in terms of refraction, well, we can see red light is refracting the least, blue light is refracting the most. Again, when they get to GCSE, and especially at A level, they'll start explaining that in terms of ideas around wavelength and frequency and so on. They need a bit of a knowledge of the electromagnetic spectrum to really make sense of that. So for now, you can just keep it really, really simple. And again, when you're explaining this to students, really emphasize this idea that the rainbow here is just the white light split apart. But when you bring all of those colours back, you end up with what you started with. So that's something you can explain to them and really, even more importantly, demo to them to show them this effect happening in the lab. The other example that you can give to them is a super simple one, one they'll all be familiar with, which is a rainbow. And again, this is just a really nice simple example of how white light and ideas around refraction can be visible. But what you want to emphasize here is that if we draw a raindrop like this, something like this, really this raindrop, especially if you look at the top of it, has essentially the same shape as a prism. So what's happening here is that drops of water in the atmosphere refracts the white light that comes from the sun. So we've got white light coming in here like this. They refract it, and what you end up with is the colours of the rainbow. So I'll just sketch these again. I'm just going to do 3 of them. You may wish to do more colours if you have them to hand, but I'm just going to do 3. And that's all it is, a rainbow. And again, please show them pictures of a rainbow and talk to the students about how, as I'm sure they will know, rainbows are formed when it's sunny and raining at the same time. Why? Because each raindrop acts as a little prism, and that refraction effect happens, and the white light that's coming from the sun is split into its various components. I'm actually going to stop the video there. That's a really simple exposition of what's going on with white light. I'll do another video to talk in a bit more detail about Newton's experiment to do with prisms. So that will be the next video.